So good morning everyone. We are now going to do the experiment number 6, which is entitled Reduction of Sample Size by Quartering Method and Determination of Specific Gravity, Water Absorption, Moisture Content, and Densities of Coarse Aggregates. And we are the group number 1, and I am Keziah Zerna.
I am Vinz, Racines.
And Hertz, Pagaran.
I am Alge, Khristian, Guia.
And for the materials to be used,
So, we're going to use coarse aggregates,
Mixing pans, flat edge soft shovel, straight edge scoop, sieve number 4.
Container, drying oven, and weighing scale. Now I am going to get the coarse aggregate, and I'm going to mix it 4 times.
Now we're going to flatten the conical pile in uniform thickness and diameter.
Next, I will divide the pile into 4 equal quarters.
so now I'm going to take out 2 diagonal opposite quarters.
We're going to sieve the coarse aggregate using sieve number 4.
Now we're going to weigh these coarse aggregates.
So after weighing the mass of the coarse aggregate, we will now wash them.
We're going to submerge our coarse aggregates.
We will now get the wasted water by weighing the excess water of the coarse aggregate. Now we will weigh the excess water from the coarse aggregate. So now we are going to remove the excess water of the coarse aggregates using a cloth.
Now we're going to put this into the oven for 24 hours.
So after 24 hours, I am now going to get the coarse aggregates in the drying oven and cool it for 1 to 3 hours, and then after cooling it, I am going to weigh it. So after cooling it, I am now going to weigh the coarse aggregates. For the raw data and results and discussions of the experiment, the first data that we have obtained is the mass and volume of the container that was used. The second set of data that we have acquired is the physical properties of the aggregate sample, wherein we gather the values of its weight in water, saturated surface dry or the SSD, oven dry weight, and the mass of aggregates. We also got the data of the mechanical properties of the aggregate sample, which includes the specific gravity, moisture content, water absorption, and densities. The mechanical properties of the aggregate sample are derived using this set of formulas. For the specific gravity, we first get its dry relative by using the formula wherein the oven dry weight should be divided by the saturated surface dry weight that is subtracted by the weight in water, and these are the results. So to solve for saturated surface dry specific gravity, the saturated surface dry weight should be divided by the saturated surface dry weight that is subtracted by the weight in water. And to calculate apparent specific gravity, the oven dry weight should be divided by the oven dry weight that is subtracted by the weight in water, and these are the obtained results using the formula. In solving the moisture content, it is computed by subtracting saturated surface dry weight from oven dry weight, then dividing it by the oven dry weight and multiplying it by 100. And it is also the same with solving the water absorption. For the normal and bulk density, it is solved by dividing the mass of aggregates by the volume of its container for the normal density, and dividing the water absorption by 100, then adding 1 and multiplying it with the normal density for bulk density. And as a result from using the formulas for the mechanical properties of the aggregate sample, a dry relative specific gravity of 1.388 kg, then the coarse aggregate sample shows that it is relatively porous and could have a high water absorption capacity. And the saturated surface dry specific gravity, which takes into account the water that was absorbed by the sample, is 1.413 kg. The volume of the pores is accounted for by the apparent specific gravity, which is 1.424 kg. So the results presented show that the overall sample has a moderate to high porosity. These findings reveal that the aggregate sample is rather relatively dry and has a low to moderate water absorption capacity. According to the results for both moisture content and water absorption, it showed that both acquired the same average value of 1.78%, and it was stated that the value should be less than 2% in order to prevent large variations in the amount of water in the concrete mix during production. And we obtained an amount of 1.78%, making the sample ideal to be used since it met the standard. The normal density of the aggregate sample is 1,454.1 kg per cubic meter, while the bulk density is 1,454.36 kg per cubic meter. The porosity of the coarse aggregate sample may be calculated using the difference between the normal and bulk densities. And in our results, the difference is small, which shows that the coarse aggregate sample has a relatively low porosity. Additionally, since the result we obtained falls within the range of the standard aggregate density of 1,200 to 1,750 kg per cubic meter, it can be considered that it met the standard. Furthermore, the average and the three samples passed the standard for moisture content and water absorption since the values were less than 2%, which is a great sample that will avoid large variations in the amount of water in the concrete mix throughout the production.